Okay, so you have this triangle. It's a right triangle. This is angle A. See, the problem says that angle B is alpha and angle C is beta. So it's asking us to explain why alpha is equal to 90 minus beta. Well, as you can see that all the angles in the triangle should equal 180 degrees, and that's A plus B plus C. So if A is equal to 90 degrees, that means B plus C has to be equal to 90 degrees also. So then basically you can substitute beta symbol and alpha symbol in for B and C because we're really talking about those angles. So in for B we'll put alpha, and in for C we'll put beta. So these two angles right here and here should equal 90 degrees. So then by just doing some algebra you can get beta should equal 90 degrees minus alpha, and alpha should equal 90 degrees minus whatever beta is. So that kind of explains why those should be that way. It's kind of hard to say what the answer should be, but from that, this is the essential part to that cofunction. And if you look at the triangle on that website, you can see that in the 3, 4, 5 right triangle, that they're talking about, that's theta, this is pi, the sine of theta is equal to the opposite over the hypotenuse, so that's equal to 4/5, and the cosine of theta is equal to 3/5. The sine of pi is equal to 3/5, and the cosine of pi is equal to 4/5. So you can kind of see here that there's like a relationship here. So wherever the sine of theta, which is one of the other, if there's a 90-degree angle, there's only two acute angles left in the triangle. So the sine of whatever this acute angle is going to be equal to the cosine of whatever that acute angle is. Because the sine is that side over that side, the cosine is that side over that side. So all the identities are saying is that the sine of theta is equal to the cosine of pi, basically. And so, but they're also saying that pi is equal to 90 degrees minus theta. And when you substitute that in for pi, that's how you get sine theta is equal to cosine of 90 degrees minus pi. Likewise, sine of pi would be equal to cosine of theta, which is cosine of 90 degrees minus theta. Excuse me, pi. Hold on, I think I confused myself. Yes, minus pi. This would be the... You get the idea. And then as far as the tangent goes, since we know that that works for the cosine and the sine, and so if like you have the cosine of theta, you know that's equal to the sine of pi. And we know that pi is 90 degrees minus theta. So it goes back and forth, it goes both ways, it works both ways. So since all tangent is the sine over the cosine, then we could say that if you look up here when we figured out what these were, the tangent of theta is equal to 4/5 over 3/5. And cotangent of pi is equal to 4/5 over 3/5, whatever that fraction turns out to be. So that means that tangent and cotangent are cofunctional, and so they work the same way that the cosine and the sine did, where you basically are just taking, all this is saying is that that angle minus whatever other angle equals that, or 180 degrees. I guess if you take up this angle, then that only leaves 90 degrees left, so that's what this is. And that's also equal to saying pi over 2, because pi is 180 degrees. So that's how it's just subtracting out the other angles to find the other one that's left. And so therefore cotangent and tangent are cofunctional, and that's all the identities except for and then secant and cosecant is just 1 over the sine and 1 over the cosine, so it's all the same thing. Once you find out that the sine and the cosine are cofunctional, then you know that the rest are going to be. But hope that helps.